In this video, I'm going to discuss what a series is. It's pretty straightforward. A series is just the sum of a sequence. So if I have a sequence, a sub n, the series would be the summation as n goes from 1 to infinity of that sequence, a sub n. If you haven't seen this notation before, it's just a giant plus sign. Means if you have n equals 1, so you've got a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus yada yada yada, on out forever. What we want to ask ourselves is, does a series converge or diverge? The first thing you need to ask yourself is, does the sequence go to 0? You can't add a bunch of numbers that don't get closer and closer to 0 and expect to get a number. This is so important. Let me reiterate it. If the limit doesn't equal 0, the series diverges. So what if the limit of the sequence is 0? Well, that means you can keep going, but otherwise you know nothing. You have to check to see, do the terms go to 0 fast enough to converge to a sum? So they not only have to converge to 0, they have to converge to 0 quickly. And we'll put a tighter definition on that. So let's look at an arithmetic series. Something of the form a plus bn. Does this converge or diverge? Well, the limit of the terms is not 0. A plus bn is going to be plus or minus infinity, which is not 0, so this sucker diverges. All arithmetic series diverge, except if a and b are both 0. Is that really a series? Don't be a smartass. That one doesn't count. But in general, all arithmetic series diverge. Okay, let's look at a geometric series. Does it converge or diverge? We need to look at the limit of the terms. As n goes to infinity, what happens to a times r to the n? A is just a constant, so it's not going to change. This is what I worry about. Is r to the n going to get bigger or smaller? Well, if the absolute value of r is less than 1, and you raise r to a really big number, you're going to approach 0. If, however, r is greater than or equal to 1, 8 times r to the n grows exponentially. And if r is less than or equal to negative 1, it does not exist, because the negative will make it flip-flop between positive and negative, positive, negative. Since the limit of the terms isn't 0, the series diverges. So if the absolute value of r is less than 1, a series might converge, but we need to check. For other r's, the series will diverge. So how do you find the sum of a series? Typically, this is hard to do. We're lucky if we can figure out if it converges or diverges, but actually to find the number that it converges to is difficult. The way we do it, for the ones we can do it, is we look at the sequence of partial sums. So let the summation from n goes from 0 to infinity of a sub n be the series based on the sequence a sub n. The partial sum is just what it sounds like. We want to look at the sequence of partial sums. Okay, partial sum would be adding some of the terms. So s sub k is the sum of the terms up through the kth term. So for example, if I have a sub n is 3 over 2 to the n. S sub 0 is 3, because I just have the one a sub 0. 3 over 2 to the 0 is 3, so I'll get a 3. S sub 1 is the sum of the first two terms, 3 plus 3 halves, which gives me 9 halves. S sub 2 gives me the sum of the first three terms, 3 plus 3 over 2 plus 3 over 2 squared, which adds up to 21 over 4, etc. So S0, S1, S2, S3, yada yada yada, that is my sequence of partial sum. So we say the sum of the series is equal to the limit of the partial sums, assuming that limit exists. If the limit does exist, the series converges to that limit, otherwise it diverges. So let's look at geometric series where the absolute value of r is less than 1. I'm going to derive a formula for you, so you don't have to use this method every time. So let's look at the partial sums. S sub n is a plus ar squared plus yada yada yada, ar to the nth. We take the same expression and multiply through by r. So r times s sub n is ar squared, yada yada yada, arn plus 1. Notice I just basically shifted everything to the right. Now I want to subtract these two expressions. So I've got s sub n minus r s sub n. And I've lined these up so it's easier to see. The ARs will subtract off, the AR squares will subtract off, everything in the middle until AR to the nth will subtract off. The only thing that survives is the A and the AR to the n plus 1. Now I can factor an S sub n out of the left side and an A from the right side. Solving for S sub n, I get this. So to find the sum of a geometric series, I need to take the limit of S sub n as n goes to infinity. I know what s sub n is, I plug that in. Note that the only thing that's changing as n goes to infinity is this r to the n plus 1, and that sucker's going to go to 0, because we know the limit is 0 of that. So all that's left is a over 1 minus r. So the formula for the sum of a geometric series is a over 1 minus r. What if you're starting somewhere other than n equals 0? Well, let's don't get all... We can get all knotted up in indexes. But first, let me show you something. Suppose I have the summation as n goes from k to infinity of ar to the n. I want that n to start at 0, so I can use my formula. N is equal to 0, I need to add k to the power so that I start on the right point. Here I have r to the n plus k, which is the same as r to the n times r to the k. Now, r to the k has absolutely nothing to do with n, so I can suck it out. This I have a formula for. Filling in the formula, I have r to the k times parentheses a over 1 minus r. Simplifying it, I get ar to the k over 1 minus r. Notice that ar to the k, well, that's just going to be the first term of my sum. If I plug k into this, I get ar to the k. So I have the first term on top and 1 minus r on the bottom. A much better equation or formula to memorize is this. The sum of a geometric series is going to be the first term over 1 minus r. Example, suppose I have the summation as n goes from 2 to infinity of 3 over 5 to the n. First term, 3 over 5 squared. My r is 1/5. That's what's being multiplied each time. Using my formula, I have 3 over 25 all over 1 minus 1/5. 1 minus 1/5 is 4/5. So if I divide by 4/5, that's the same thing as multiplying by 5/4. Simplifying this, I get 3/20. So geometric series we can find the sum of. Another type of series we can find the sum for are telescoping sums. This is easier to see through an example. Suppose I have the summation as n goes from 1 to infinity of the natural log of n over n plus 1. Using my law of logarithms, one of my laws of logarithms, I can rewrite that natural log as the natural log of n minus the natural log of n plus 1. Okay. So let's write out the first term of this. If n equals 1, I have natural log of 1 minus natural log of 2. Okay. Well, now if n equals 2, let's do the next term. I have natural log of 2 minus natural log of 3. Notice I have a negative natural log of 2 and a positive natural log of 2. They'll cancel. Let's do the next term. I've got plus natural log of 3 minus natural log of 4. This time, the natural log of 3's cancel. And this is going to continue on. So the only thing that survives for s sub n is that natural log of 1 minus the natural log of n plus 1. So what is the limit of s sub n as n goes to infinity? Well, that sucker goes to infinity. Natural log of n plus 1, natural log of infinity is infinity. So this series diverges. Let's try this one. I have the summation as n goes from 2 to infinity of 2 over n squared minus 1. I want to break this up. I use the method of partial fractions to get the summation from 2 to infinity of 1 over n minus 1 over n plus 1. If you don't remember partial fractions, there's a video link for that in the comments below. So let's write out the first few terms. Okay, a few more than just a few terms. So let's see what cancels out. We have 1 over 1 minus 1/3, 1/2 minus 1/4. So far, nothing cancels. The next one I get 1/3 minus 1/5, also known as 1/5. So the 1/3s cancel. Next one, I see that the 1/4s cancel, and then my 1/5 will cancel, and my 1/6 will cancel. They'll keep canceling out. So the only thing that survives is this 1 and 1/2. So the partial sum is 3/2 minus 1 over n plus 1. So let's take the limit of this. So I have the limit of the partial sum. Notice that 1 over n plus 1 goes to 0 as n goes to infinity. So my limit is 3/2, which means the sum of my series is 3/2. So what we will be focusing on is geometric series, finding their sum, telescoping series, if we can find their sum, and looking at series to determine if they converge or diverge.